So my journey into bare dust collection started with envy of capturing dust centrifugal dust collector design. Then it led me into some of my own horizontal centrifugal dust collector designs, experimenting based on something similar to the Harvey Woodworking Pro dust collector models. And now I'm on to trying out a dual vertical Cyclone design. My name is Corbin Dunn, and this video is all about my 3D printed dual Cyclone separators. This is a completely open project, so all my files on how to actually go ahead and print this for yourself are available completely for free. The link will be in the description for the STL models and my original Autodesk Fusion drawings. Goals. I want to support a 3 horsepower blower and 6-inch ducting, specifically so I can convert my old Grizzly dust collector into a Cyclone. It needs to have a consistently high separation rate, something greater than 99%, and it needs to be efficient where it's not going to drop the static pressure a lot. I want to keep high CFMs directly at my machine to remove most of the dust. My second goal is to keep it cheap. So let's talk about costs and how much it costs to actually print this system. It costs roughly $80 in PLA, assuming you can get PLA for about $14 a kilogram shipped to you, which is quite possible if you just go buy it in bulk from Bambu Lab. You can get it a lot cheaper too, so $80 might even be on the high end. Other parts that you need to complete a system like this, you need a container for all the chips to go into. I found a 55-gallon drum on Facebook Marketplace for about $12.50. So your cost for that may vary and what you want to actually use. You might be able to use a garbage can or something else. I also used a lot of screws, random plywood scraps that I already had around the shop, and some really cheap $2 or $3 tubes of caulking. So the total cost for this project are probably about $100, which is really, really cheap. But the big elephant in the room is the 3D printer itself. Printing these parts require a pretty large format printer, and I have a Bambu Lab H2C, which I spent over $2,400 for. Granted, you can get a little bit cheaper of their models for around $1,200. Still spending over $1,000 on a printer to build something that costs $100 probably isn't cost effective. My third goal is good filtration, and that's something I'm going to work on in another video. And I would really love HEPA quality filtration, but I'm going to settle for something a little bit lower, like MERV 15 instead of MERV 17 by using some wind filters. Design. So I'm going to go with a dual Cyclone system, and there's a very practical reason why. And if I look at this, this width is the largest size that I can print on my 3D printer. So I'm maximizing the biggest Cyclone I can print. If I look at the area of what a 6-inch diameter inlet can have come into it, a single Cyclone would have just too small of an inlet and too small of an outlet to actually support the amount of chips that could go through a 6-inch port. So instead, I decided to split it equally into 2 Cyclones that are mirroring each other. Now, there are some advantages to having 2 Cyclones instead of 1. Because the air is coming in and going into 2 smaller chambers, the velocity is going to increase. An increased velocity is going to have smaller fine dust separate better because it's spinning faster out to the edges of the Cyclone cone. There are disadvantages though, and the biggest disadvantage is they're going to have a higher pressure drop. The static pressure is going to be higher in the system. Exactly how much I would like to measure, and eventually I may get to doing that. But for now, I'm going to ignore that because I need 2 Cyclones for a 6-inch intake and a 3 horsepower system. So I set about designing this in CAD using Autodesk Fusion. And one of the things I did is I made the inlet height be very tall and narrow. And this is really based on information from Bill Pence, who did a lot of Cyclone design. And the general recommendation is that the inlet width should probably be about 20% of the Cyclone diameter, and the height should be about 50% of the diameter. So these are all parameters which allows this design to really easily be customized and changed to test different variables. Printing and assembly. I printed these guys out PLA because it's cheap and easy to do, and I did 2 walls and 20% infill using gyroid, nothing fancy at all, and it did seem strong enough. I explicitly printed it upside down to keep the inside of the Cyclone rather clean, so the supports on the outside had to be popped off. Once I had one Cyclone designed, I could create a configuration and do a mirrored version. I could then create a new document inside of Fusion and insert each of the Cyclones into it, one with the mirrored version. And then I could go ahead and just create tubing and whatnot that would work entirely around it. My original plan was to print everything out of translucent PETG, but I didn't have enough of it at the time. But a few of the parts are translucent PETG. However, I realized the supports are really hard to remove from PETG, so I need to look more into printing PETG with supports. Once I had all the parts printed, I could do some assembly. I made the inlets be a separate piece that was simply glued on, and this is just so I didn't have a really rough transition area where the other tubes would simply slide into it. I used some CA glue to glue it on in and some cheap white caulking to caulk the back of it to make sure no air could get out. The red PLA outlet adapter slid on really easily and made a nice tight seal, and this would allow me to remove it and make some changes. However, the part that goes on, the Y portion, the way I designed this really wasn't quite straightforward enough. I just split a loft in half, which made the shapes not fit together. So I had to soften up the PLA a little bit with a heat gun, and then I could just squish the other part into it and caulk and glue it together. The 6-inch inlet Y adapter pretty easily slid on in and held together nicely with some friction. Later, caulking it would provide less air loss. I glued and caulked the Cyclone cone bottom together because it just can be a permanent piece. But the Cyclone top that attaches to it, I ended up just taping it together because I may want to experiment with different cone shapes. Dust collector mods. Once I had the Cyclone built, I could start on modifying my dust collector. At this point, I had to commit to it and take my old collector apart. So I had to run my CNC without any dust collection, and here I'm cutting out the dual dust outlet ports to support the dual Cyclones. It's just a scrap piece of plywood I had laying around, and I simply screwed the Cyclones onto it. I should also caulk it, but at this point I'm just finding a test position, and I needed the piece as a template for positioning everything else around the right location. The dust collector motor and impeller are going to be mounted on my wall. I cut out some more plywood that was large enough to hold the impeller, and I made a strong box with glue and pocket hole screws. The dust collector impeller will sit on this box, and I did some rough positioning with the outlet port template to figure out the approximate location for the suction port to go. And a lot of precision isn't really required here, so I rough cut the circle out with a jigsaw and made it larger than the port inlet so I could have some wiggle room to move things around. I could then beef up the rest of the box a bit, and a lot of this is just working out how to work around some of my conduit that's running to my machines. The box has to be really strong and secure as the motor is pretty darn heavy. I made sure to screw it into some studs and the header that supports my back wall. And the motor was really heavy. I wasn't even sure if I could slip it into the hole on the inlet without dropping it on the ground, but I managed to get it done. I could then assemble the Cyclone support a little bit more out of the plywood. I added a back piece that would be screwed to the wall studs and some supports on the sides. At this point, it was just a lot of eyeballing to align things and getting stuff into the right position based on where the motor really ended up. And then I could go ahead and screw the Cyclone supports to my wall after making sure it was level. Underneath the Cyclones is an outlet port that is sized large enough for some standard 4-inch flexible tubing. I'm hoping this won't become a bottleneck where clogging will happen, and only time and testing will tell. If it does start to clog, I'll have to design some 5-inch outlet ports and make the Cyclone wall steeper, which might help better with separation anyways. The mating ports were eyeballed on top of the metal drum lid, and I cut out some of the holes. This is just a metal cutting blade on my jigsaw that I'm using to do it. Nothing fancy here. I used caulking and sheet metal screws to attach the outlet ports to the top of the metal lid, but later I changed them out to 1/4 bolts and nut just to avoid the sharp ends on the bottom of the lid. And the whole purpose of doing this is to just use a little bit of 4-inch flexible tubing to attach the drum to the Cyclones, and that way you can pop the lid off and move it up a little bit to get the drum out and actually empty it. The blower inlet port simply has a piece of 6-inch PVC that slides up to attach it to the actual Cyclone tops. And then I just use tape to attach everything together as a temporary first test. And this is a terrible autofocus video, but my first test, I didn't even have an outlet collection bag attached, and just to see how much dust would come through, and I did get quite a bit of chips through, so something was wrong. And I had a pretty good idea what the problem was, but before I decided to correct it, I wanted to add the outlet bag. And I simply built some shims to attach the old outlet bag collection and bag filters to the outlet port of the dust collector, just to have something until I actually build something with HEPA grade filtration. So I realized there were two problems, and the first one was a lot of static electricity that was causing the chips to not actually drop out. This is easy to solve with some Havoc metal tape that you can ground with a copper wire attached to something like the conduit, which is grounded. But the biggest issue were leaks in the system. If the vortex gets disturbed, it won't be efficient at all and chips will make it through to your filter. So I used my beekeeping smoker to blow some smoke around and find out where I had some leaks. And sure enough, I had a huge leak on the lid of the 55-gallon drum. Smoke was just getting sucked in at a rapid rate. And so I put some window sealing around the lid. Eventually I moved it to the underneath of the lid instead of on top of the drum, and I verified that this solved the leak. I could then backlight the Cyclone and I could verify that it seemed to be working really well. I couldn't detect any particles getting through to the bag filter. Now it's time for some ad hoc efficiency tests. I emptied the bin and I measured out 1 kilogram of sawdust and put it into a bucket. I then sucked out the sawdust as quickly as I could with my 6-inch tube. I then poured out everything that got collected into the 55-gallon drum and weighed it using my very imprecise kitchen scale. And I did this twice. I didn't really want to spend a lot of time on efficiency tests. The second time I just made sure everything was clean on my ground and poured the 1 kilogram of sawdust onto the floor and vacuumed it on up. Okay, so I was measuring about 994 grams that would come out of the 55-gallon drum. So that means it's about 99.4% efficient, which is pretty good. But my measuring technique isn't the greatest. A lot of people like to measure how much passes through the system and gets out. So they'll measure like the bag or their filter or weigh it. And I don't have it quite set up to do that yet. Once I add a filter, maybe I'll do some tests to see how much of a difference I am getting in efficiency when I measure it that way. And the reason why is because you get a lot of dust just stuck in the system that's not accounted for by doing it the way that I did it. So where do I go from here? It would be interesting to measure the static pressure drop that I get from a dual Cyclone system compared to a single Cyclone system. And that way I could know if I'm actually losing some CFMs at the machine due to excessive pressure. The actual impeller that's used in a dust collector like this, where the dust goes through the impeller and out, they aren't very efficient. They're designed for moving chips and not moving air. An aerodynamic impeller, where it doesn't have to actually move chips, are a lot more efficient at moving air, so having a different impeller would help a system like this. I think a dual Cyclone system like this has a lot of potential. It'd be really interesting to see how well it does on fine dust like MDF. That isn't something I cut a lot, but it'd be just interesting to see how much more efficient it would work compared to a single Cyclone system. Cost-wise, a system like this is pretty cheap. You could probably find an old used dust collector around 2 horsepower, maybe $200 to $500 on Facebook Marketplace if you look around for a while. So you could make a system like this for really cheap, especially if you already have a 3D printer. I think for me personally, I'm going to test it for a while. I ripped apart all my dust collection ducting because I want to redo it to be more efficient. I just had way too many 90s and way too many direct Ts, which are not good for a dust collection system. So once I'm back up to using my machines a lot, I will know how well this really works. I also will know how well it filters once I finally add a better filtration system than the bag filters. I love to know your guys' thoughts. Download the files, maybe print your own, and yeah, let me know what you think. Bye everyone.